Well, g'day, Max here again. Welcome back to the shop. So, last episode we completed the scraping on the column as far as we were going to go at that stage. I am happy with the result considering the measuring gear that we had. You've got to, in these situations, you've got to be able to get it done, make do with what you've got. So, what I plan to do now is we'll get our column stood back up on end. We'll bring the knee over, and there's a fair bit of damage on the mating way to the side that we done a repair on. So we'll get that, scrape that leveled out as best we can. We'll get the gib strip touched up, and we'll start our test fit procedures. It's when we start doing our test fits, and we'll be using various methods of it, to tell us, so we can pick up where any remaining high spots are. So we're just making the knee fit the column as best we can. So let's get cracking. So while we were standing the milling machine column back up then, I had the soft sling wrapped around the top of it here. You wouldn't have seen it, but I had a bolt through there, through this hole in the casting. This is where the coolant line normally comes out. So the sling is underneath that, and this bolt stops the sling slipping off the top. Right, we've got our knee up on our table. So a couple of points of interest here. This cross-hatched area here is a relieved section. So the knee contacts the first 4 inches up there and the lower 5 inches or so, 5-6 inches down there. Now, because this center section here is relieved, that provides a gap between the way on the dovetail way on the column in here. So there's nothing really stopping chips. Okay, you've got lots of fine chips here. There's nothing really stopping those chips working their way into this area and getting caught. So that could be another possibility why we've copped so much damage here. Now these chips, I don't know how long they've been in there for, but they have managed to work their way past the way wipers. Some pretty big ones in there. So they've been in there for a fair while. So we'll get all this cleaned up, and then we'll scrape there to there, there to there, just to smooth it off, and then we'll have a test fit. The other place where these chips get down here is off the top here, and they can fall directly down. There's nothing stopping them, and yeah, they will obviously work their way across. They'll fill up in the bottom of the casting. All of these chips here are from me, as I have had this casting cleaned out before. I've never had the casting off the machine before, but I have had it cleaned out when I first got the machine. So you wonder, there's some pretty big chips in there. You wonder how they get in there, but they do. So anyway, let's get this sorted out. Another interesting thing to note too, inside the casting, you Here's the symbol here. 40, then a gap, 78. No idea what that is for. There might be some Bridgeport gurus out there that can identify that. Does that mean that quite possibly this was cast in 78? Who knows? Inside the main casting is the same symbol, the tree symbol 4078. So yeah, whether that's a reflection on the year 1978, quite ironic, that's the same year as when I first started machining. So right down the bottom of the V, where this blue line is, there's a ridge on both ends. So that's worn out. Well, that's what's left from original height, top of that ridge. So I want to get rid of that ridge. So I'll get that off first and then pass along the flat area. Okay, that's got that ridge taken care of, so we'll do a full scrape in two directions down the remaining face. Okay, that's our initial rough scraping in both directions. So we'll get this cleaned off and we'll run a straight edge across it with some marking glue and just see how we're looking. Okay, after that first initial rough scrape, we've got a fair bit going on down here we can pick at. Now come up the other end. We're a bit lighter on it up here. So we'll pick away at the highs and bring this down level as we can. Slowly coming in. So I'll keep going till we get a bit more, a few more high spots showing. Well, the electricity company Western Power have been in and just snipped the line between the lamppost and our house, so we've got no power now for several hours. The electrician is and also the power company are doing the connections for our new power supply, so eventually in a few hours time we'll have our power back on in the shop here, hopefully this afternoon. So in the interim I've been pecking away at this down here. So up the top we're starting to get some good coverage up the top. down the bottom we've probably got 50% of what we really need on a unworn machine. So what I'm going to do now, I'm going to stop here, because you've got to weigh up. This is going to be running on an already worn surface, so we've got that to deal with. We've got any inaccuracies with our straight edge that we are using to glue this up. So, and we don't want to over scrape and scrape this reasonably flat to an unknown edge, knowing that it's going on a worn surface. Thereby we could be inducing extra inaccuracies into the machine. It's always a possibility. So we're going to halt that there. Our gib strip, which isn't actually that bad, so I'm going to knock off just this little lip that runs down the length of it, and then we'll fit the knee up to the column and have a bit of a test fit with some blue and just see if we can pick up any really obvious tight spots or things like that. So let me get this let me get this gib strip sorted, and I'll bring you back when we're lifting the knee on. Hey, we finally have power onto the shop. So the board here, she's all connected up and turned on. So yeah, we've got a lot to go on yet in here. So for now, so we've just got a 32 amp 3-phase outlet here and a 15 amp double outlet here. At least I can run leads to whatever I need to until I get the time to run the power wherever it's got to go into the shop. But yeah, we can run the full complement of lights now. Do have a heap of single phase outlets up the other end of the shop, but in the main area here we still have to run all those, and of course the wiring for the machines. But the major step, well, that took nearly a year and a half, I suppose, all up to get power sorted. So yeah, we're on our way. Okay, so after our scraping, we've blued up with a Sharpie the two areas of main contact where the knee rides on the column, and lightly oiled the slideways on the column, and blued up the gib with a Sharpie, so that's all ready for a test fit. So I've gone with the Sharpie marker in the hope, I mean, it's worked for me in the past, it'll just pick up any maybe problematic high spots. I've used blue, the marking blue before, the bearing blue, and that's sometimes works, sometimes it doesn't. You get misreadings, I've found. So we'll try it, we'll see how it goes with the Sharpie marker. So we'll get this, we'll get her plonked on and see how she fits. bloody Bridgeport. I didn't plan that one very well. Let me just reposition the sling. The jacking screws hitting on the timber underneath. Or I can just screw it down out the way. Give us a bit more clearance. Right, try again. Be alright. Okay. Slip our gib strip in. And find the screw. There we are. Yeah. Okay, we'll nip that up for now. Lock the knee. Pull this one out. Okay, should be able to keep lowering now. So we're just lowering down to the top of the thread, enters this gear. Line up, there's a keyway that has to be lined up. Okay, so I'll go and get the keyway and the nut. We'll temporarily install those, then we can adjust up our gib strip and give her a bit of a wind up and down, and we'll go up and down a few times with it adjusted quite firmly, and just have a feel and see if there's any tight spots that we're picking up. And if there is, it will show up clearly on the either the gib strip or the other side where we've put the Sharpie marker. So we've run the knee up and down several times now on our Bridgeport here, just to try and get a reading off that Sharpie marker, the blue that we put on the contact areas. So I have an indicator set up here just to help me just get the gib strip adjusted right, and everything feels really good for an old machine like this. So we'll bring you in, we'll show you, we'll go through the readings with you. So we'll start off at the top, our indicator's zeroed out, so we'll start winding down. You see it flicker a little bit with the flaking. So we're down about 4 inches there, and see it's drifted off about half a thou, but I lock the knee and she comes back up to probably 2/10 over a 0. Depends if the indicator's sitting in a crater, flaking crater. Yeah, probably 2/10 over 0. We'll come down another 4 inches. That's about mid-travel there, and we've lost a thou, probably a thou and 2/10, so relock the knee, and we're minus half a thou. That's halfway, 50% of its travel, or a bit over 50% of its travel. About in this area here is where it generally works the most. So I'll just give the knee, I'll give it a good shake, side to side, and we're getting plus or minus probably 3/10, 2/10. So I'll keep going down, bottom of its travel. Oh, we didn't lock the knee here, did we? So I'll lock the knee, and we're minus 2/10, 2/3. Might have to adjust the camera. Yeah, we'll bring you down a bit. We're heading down, we're sitting on minus 1 thou. Lock the knee again, probably about 8/10 there, minus. Go all the way to the bottom. That's all the way down there. So we're sitting on minus a thou. We'll relock the knee. We're minus half a thou. So if I loosen the knee, we'll give it a shake. Yeah, it's probably 2/10 either side, so plus or minus 2/10. Either side of the minus 1 thou division. Lock the knee. Minus half a thou there. So that's in good shape. We're on 0 at the top, we're half a thou there. Lock the knee, probably plus 2/10. Halfway down its travel. We're minus 3/4 of a thou, lock the knee, probably minus 1/10 if that. Head down to the bottom of its travel. Out there. We're minus about 7/10. We'll lock the knee. Minus 8/10. So it's all pretty well within a thou, our readings. That's our readings taken in this method. Yeah, so I'm really happy with those results. I think it's come up extremely well, or considering what we had to work with. So we'll slip the knee back off now, and we'll have a look at the blue contact areas. Plus I need to give the boiler holes a good flush out there too, to make sure we haven't got any chips gone down them from scraping. So I'll get the hoist set up, we'll get our knee lifted back off. So if we look at where our knee was contacting, on the upper section from there up to the top, you can see we've got just over 50% of the Sharpie worn off. Now, interesting to note is when we check this with our straight edge of unknown quality, we were getting quite the opposite effect. We were getting our contact on the upper 50%, not the lower. So I think we picked a good time to stop, seeing how we have reversed our contact there. Heading down to the lower, okay, our area starts from, or our bearing area starts from there, top of the blue, and goes down. So it does thin out a bit up here. It's a bit hard to get the camera in here, but we've got enough there for all intents and purposes, if you take into consideration the wear that is in there and the wear on the column. So there is light wear on all of these surfaces as well, more so down the bottom than the top, which you'd expect due to the way that the knee actually hangs onto the column. As far as doing anything on these surfaces at the moment, take into consideration the slight wear that we did pick up in the column. Realistically, I think you'd be flogging a dead horse. What I would do if I was bringing this back to new condition would be remachine both of these, and also get my surface plate sorted out. And then if we go to do these later at a later date, we still have a reference area on the very end here, and on the other very end here where there's no wear. There's approximately 1 thou wear in the middle here, but using those two references there in conjunction with the top setup on there would put you in a good position with a master square to bring these back to where they should be. So that's something we can sort of look at, maybe tackle at a later date when all of these other machines in the shop are running and I have the suitable straight edges and my surface plate sorted out to tackle that job. But like I said, I think if we go any further, we're just going to be pissing in the wind, and we do run the risk of causing harm to the accuracy of the machine. So I mean, this machine still holds quite reasonable tolerances, you know, for its age. So I think we'll get the knee fitted back on, saddle and table fitted back up. Yeah, so basically in a nutshell, I think I've gone as far as I'm game enough to go at this stage with the gear that I have. We did manage to cure our knee issue with it sticking up on the top, and that was our main goal. So we've achieved that. We haven't really upset the balance between scraping places we shouldn't and upset the accuracy of the machine. So I think we're in a good place. So I'll put the table and the rest of the machine top back on, rest the machine back together off camera, as it's not really a Bridgeport assembly video. There's hundreds of them out on the internet. We will be doing a milling machine, partial disassembly and assembly on the big mill directly after we finish the JFMT lathe, which is our next project to get that up and running. So there you have it. Stick around, I've added a little bit on the end. I was just doing a little fabrication sheet metal job, so it's just a little quickie at the end. Geez, it's pouring with rain outside, so well I guess it is autumn. The other week I had a visitor drop in from Eastern States to come and say good day and have a look at the shop, and he brought with him a gift for me. So what we have here is a transformer to reduce our 240 volts down to 24 volts, and with it the speed controller, 24 volt speed controller. So you have a little digital readout there for your RPMs, little potentiometer to adjust the RPMs, and this electric motor. This is a 280 watt electric motor, 24 volts. This is, yeah, well, that's 24 volts. So yeah, 24 volts DC. Also, he dropped me off some of these. So these are, there's a 2000, a 400 and a 1000 diamond, like a diamond lapping wheel, and that was straight after I'd ordered one on eBay. This one's a 1500. So I did have the intentions of making a grinding tool for doing the lapping on our scraper edges as we advance in our learning curve about scraping. So, bugger me days, a week after that arrived, I had a package in the mail for a nice chap over in the USA, and he sent us it's a sharpening stone, a tapered sharpening stone, which is just what you need, and these little babies here. So these are the Sandvik scraper blade edges. Carbide edges for the scraper, proper ones. So what we'll have to do is make up a radius grinding attachment so we can grind these to the appropriate radiuses required. And now we've got all this gear here, we can make up a lap, diamond lap, so we can sharpen them as they're supposed to be sharpened. So that's another step forward in our scraping journey. So thanks guys, much appreciated. We can't get these here in Perth. I've searched all over the web, and the closest ones I can find are in Poland. So I just thought I'd squeeze this one in. Every now and then in the machine shop, you've got to do your fair share of welding and fabrication. Well, at least in a job shop environment you do, and you need to be pretty competent at it. When I did my apprenticeship, a big part of that was welding and fabrication, as well as machining. So bring in, we'll show you what we've got here. It's just a little box, and this box protects the power cables that come into the new workshop here. So it's just a box made out of 1.6 millimeter sheet steel. So just got the cutouts to clear the concrete slab and bits of the wall, and comes up, and it's just an enclosure so the electrical cables run inside protected and can't get damaged from an outside source, being me. So just a point of note with this, what I like to do is make sure all my joints don't have any gaps. So it's where you take your time when you're cutting the material out, and try and set it up so you're just doing a corner weld, so the pieces aren't overlapping. You've got it as best as you can on the corner. So you can see just up here I've got a little gap. So I'll hammer that tack down to take that gap out of it. Otherwise we'll end up blowing a hole through, and it's just a pain in the ass then. Looks like crap. Right, let me get that sorted. And our welding, the way we're going to weld this is all going to be vertical down with the MIG welder. So, and we're just going to be going down like that, all the way down. Now, I'm using my little 180 MIG welder, little Lincoln, and I've got it turned right down. Y speed's set right down, just below 2, and the voltage is just below, well, it's in between C and D. So it's just turned right down, as there's no real strength, structural strength required in this part, and there'll be enough weld on it to hold it. And so, with the magic of Mr. Bosch and a sanding disc, we can tidy up all our edges to nice straight edges. hide all our sins. There's no hiding your sins in sheet metal, because all you got to do is turn it around. See how many blowholes you got. And we've got none. Good penetration all the way through. So that's why we did the setup, doing vertical down with the corner weld. The vertical down, you can travel a bit faster, and you're not directing quite as much heat into it. So we haven't distorted anything. So come out well. So these are the little mounting tabs which will hold it to the concrete. So with a little weld down there, that's all it needs. So this is before, where the cables enter in the workshop, and this is after. So they'll all be properly, fully protected. So if any of you have got these little single phase MIG welders, and I know a lot of people have, one major issue, well there's two major issues with these, is voltage fluctuation from your power supply, whether you're in a residential area or whatever, and the other one is the earth. You've got to have a really good earth for these welders, or most welders, and with these little welders, the earth lead, you feel it when you've been doing a fair bit of welding, it gets quite warm. So my opinion, and that's just my opinion, the earth leads on a lot of these small machines are too small. And I had a couple of stops and starts with welding, and what's happened, I think, was because I've shifted this welder over here on the back of a trailer, which has been bouncing around a little bit, and some of the wire on the spool got a bit jiggled around. Like, I'm only using 0.9mm wire, so, but yeah, main thing with them is your earth. You've got to have a really good earth. And the other main thing with them, if I can find it, here we are, make sure that your tip hasn't got a lot of wear in it, because that will affect the performance greatly. And every now and then, pull your gun apart, pull a lead off it, and I blow compressed air through the liner. There's a liner inside the lead which the welding wire travels through. So just a couple of basic bits of info on these little welders. I'm running just straight Argo Shield light gas on 15 litres a minute. But they can be quite a good welder. They can be a very good welder, but they can be very temperamental. So this is my other welder. It's a Unimig 300 amp MIG welder. This is a very good welder, this thing. So we run 1.2 wire in this. Now I've got the 32 amp plug set up over the other side of the workshop. We can get this cranked up as we, I have a little job to use this on. I showed in an earlier video we were using this welder when we were making parts, the poles for the veranda here in the shed. This is the welder that I was using in that. And also we had a few shots using this welder using 1.2 wire spray transfer. So that's when you got the everything cranked right up and it's just spraying the weld on. Creates a lot of heat but gets it done really quick. While we're on the subject of welding, we'll get this thing cranked up too one day again. This is our tacked spray torch, Utiloy torch, and runs these eutectic powders for building up surfaces. So we've got this one, and we've also got this one down here, the eutectic Castellan Rototech. So this is building up warm journals on shafts and whatnot. So yeah, that's the torch. This is the same as the one that Adam Booth used to use in a lot of his earlier videos before he updated to the later model. So yeah, that's the handpiece. That's the torch. The powder goes in the end there. We do have a good handful of powders and the masking agents as well. So yeah, this will be a good one to have a play around with at a later date. Cheers, take care. Hopefully we'll see you in the next video where, well, this will be ready for wiring, and yeah, we should be looking at the last jobs that we have to tackle on the JFMT lathe, and there's still a fair bit to go on that one. So anyway, cheers.